Okay, here starts the fun. Differentiation. And these are simple rules. Okay, first of all, definition. What is differentiation? It's the process of finding a gradient function. And another word for this is derivative function. And remember, gradient is the same as slope. Which is the steepness of a line. All right, first of all, I want you to look at this investigation number 1. We're only going to look at part of this investigation, but what I want you to do first of all is just differentiate from first principles so that means using that formula and there's 3 questions that I'd like you to look at. A x squared, so differentiate that from first principles. Also x cubed, and also x to the power of 4. So please pause the video right now, and I would like you to do those 3 things. Okay, here we have the first 2 done. We have f of x equals x squared. So using our first principles derivative formula, the derivative is equal to the limit as h approaches 0 of x plus h squared minus x squared all over h. Do the algebra down until we end up with 2x plus h. So therefore, as h approaches 0 here, this function will just equal 2x. So the derivative of x squared is 2x. Similarly, we have f of x equals x cubed. Therefore, the derivative formula with using first principles is this. Do our algebra down until we end up with 3x squared plus 3xh plus h squared. As h approaches 0, this will become 0. This will also become 0. And we're just left with 3x squared. So the derivative of x cubed, is 3x squared. Okay, and this last one here, f of x equals x to the power of 4. The derivative is the limit as h approaches 0 of x plus h to the power of 4, subtract x to the power of 4 all over h. We do out that algebra until we end up at this step, at which time we can see the x to the power of 4 minus x to the power of 4 equals 0. So they cancel. Just adding up our like terms then. X cubed h, there's another one of them, and that's the only one. Okay, so 4x cubed h. Similarly, we've got x squared h squared, and another one here. And that should equal 6, I believe, instead of 5. So where did I go wrong? Oh, this term right here should be squared. Okay, so then we have a 6, x squared h squared. We've got x h cubed oh yeah, and I already used that, xh cubed, so that's 4xh cubed plus h to the power 4 all over h. Factor out an h. Four x cubed plus 6x squared h plus 4h squared plus h cubed. And as h approaches 0, this number will become 0, this number will become 0, this number will become 0, and so the limit just equals 4x cubed. All right, so we had these three functions, and they resulted in these derivative functions. X squared resulted in 2x. X cubed resulted in 3x squared. X to the power of 4 resulted in 4x cubed. Okay, so looking for a pattern here. The pattern actually is the coefficient is created by multiplying the coefficient by the exponent. Okay, so in other words, the exponent here is 2, the coefficient is 1. Multiply those together to get our 2 here. Okay. The exponent here is 3, the coefficient is 1. Multiply them together to get our 3 here. Exponent is 4, coefficient of 1. Multiply them together to get our coefficient over here. Okay, the rule for the exponents. Exponent is created by decreasing the exponent by 1. Okay, so the exponent here is 2. Subtract 1 is an exponent of 1 here. Exponent here of 3, subtract 1, exponent of 2. Exponent here of 4, subtract 1, exponent is 3. That is the basic simple rule of finding the derivative. So let's write some rules out, some actual rules in general terms. If we have f of x, we're going to look at c, which is a constant. We're going to look at x to the power of n. We will look at c multiplied by x to the power of n. Or in other words, another way of writing that would be c multiplied by another function. We'll call that function u of x. And we'll look at two functions, u of x plus v of x, two functions added together. All right, the derivative in this case for a constant is 0. Okay, it has no exponent. In other words, the exponent is 0. 0 times c would be 0. Here we would bring our exponent down, multiply it by the coefficient, which is 1, x, and decrease the exponent by 1. Here we just multiply the c by this other rule. So c multiplied by n. So here we have a coefficient. We have a coefficient in this one. Here's our coefficient. Here's our exponent. So we said the rule was multiply the exponent by the coefficient. Well, that's the exponent by the coefficient right there. And then decrease the exponent by 1. There it is there. Okay, another way of writing this would be we could multiply the constant by the derivative of this function. And this is just take the derivative of the first function and add it to the derivative of the second function. Okay, these things all have names. We would call this name of rule. We would call this the differentiating a constant. This would be differentiating x to the power of n. Pretty simple, just what it says. This is differentiating a constant multiplied by a function. And this is called the addition rule. Here's some basic examples here for each of these. If f of x equals 7, then f dash x, the derivative, is 0. If f of x equals x to the power of 5, we haven't looked at that one yet, then the derivative is 5x to the power of 4. If the function is 4x cubed, then the derivative would be 12x squared. If the function is 3x cubed, one function, plus another function, which happens to be 5x squared, then the derivative of this is just the derivative of the first term, the first function, so 9x squared, plus the derivative of the second function, so 10x.